scientist, and he will talk today about the history of Neptune. It's a great pleasure. And I want to say that this is a joint event with the Institute of Mathematics, with Sexa Matematica, so here are our students, and cooperation with the Observatorio Valongo Institute. So thank you so much for having this great opportunity to have it's like yourself.
Thank you.
Please, the floor is yours.
Thank you. It's really a pleasure to be here. It's first time in Rio, first time in Brazil, and I'm enjoying it, which is good. But the talk I'm going to give today is not really what I'm working on every day. It is more of a hobby. It is very much related to astronomy. As you see, it is going to be about the discovery of Neptune, but in particular about the German perspective on this discovery. And why am I stressing the German discovery? You'll see as I go. So the first thing is that discovery of Neptune is one of most famous cases in history of science in general. It was very much popularized in many, even books that people write about, how things happen and so on. For general public, it is not just a topic for research. But it is also a very infamous case, as you will see. There are many different things that are weird or comical to be said about this discovery. But I want to make two claims. The first claim is that this would be a great story for a TV soap, because it's about success and failures. It's about rivalry between young and established underdog and top dog, England versus France. We always like to watch England versus France. Cambridge versus the world as well. But there is a scandals. There, at some point, people were talking about a conspiracy theory as an interpretation of what happened. But what is really true is that this is a theoretical prediction that turned out to be spot on. Not always the case with theory, but in this case, it was really that what happened. So my second claim is that discovery of Neptune is a kind of a first modern scientific discovery. It is a showcase of how modern science works, and in a way, if you want, that is when our modern science started. This is also start of invisible astronomy, but I'm not going to talk too much about it. But it is, however, linked to many things that we do in astronomy today. The other thing that is important for this talk is this German perspective on the discovery of Neptune. Why am I stressing it? Because it is typically ignored in the literature on the topic. The literature is focused on the French and on the English point of view and what happened in these places, and German part is typically forgotten. Now, there are at least 4 reasons why this should not be the case, why German part is important. One is that Neptune was discovered in Berlin on 23rd of September 1846. There is no alternative truth to that. That's it. This discovery was enabled by a German scientific project that I'm going to tell you about later. This was the instrumental thing without which the discovery probably would happen soon, maybe within 10 years or so, but it would not have happened as quickly. Then, as you will see, and you might not think of it, but naming the planet was a big controversy, and it was the German sort of influence that settled the today name that we have for this planet. And finally, which I think is very important to mention, there are also scandals. As I said, there were many scandals around this thing, but there are also scandals in Germany related to the discovery. And more important, there are some omissions which are still perpetuating, and we are here to sort them out. But one thing that you need to be aware of is that at that time, in 1850s, there was not such a thing as Germany. This is the map of German lands at that time. Every color is a different state, different kingdom, different empire. In comparison to France and England or Britain, it is very different entity, right? There is only a cultural idea of Germanness, but not a state. So that also does influence a little bit how people are thinking about the discovery. But all right, let's start with the story. About half of the talk is going to be about what actually happened, and then I'm going to go to this German part of the story. So the story begins here. This is a town of Bath in England, a beautiful place to visit. And it starts there because in the middle of 18th century, an economic immigrant from Germany came there to teach rich British kids music. His name was Friedrich Wilhelm Herschel, or William Herschel as we know him today through his anglicized name. He was, as I said, a musician, but he liked astronomy. He was a great amateur astronomer. He was making his own telescopes, grinding the mirrors. He even introduced or brought his younger sister Caroline, to come to work with him to really help him make the mirrors. And this is one of the telescopes that he used in sweeping the sky, looking for various things, among which were the binary stars. And on the 13th of March 1781, he discovered one star that moved from the previous sweep, and that turned out to be the planet of Uranus. This, of course, was a big astonishment because this is the first time since ever that something as new as a new planet was discovered in the solar system, right? Until then, the solar system finished with Saturn, but now we had something new. Of course, he made a great splash. What was very quickly discovered is that actually Herschel was not the first one to have seen Uranus. It was observed in various catalogs of stars before, but people didn't realize that this was a planet. They thought it was a star. And some of them went all the way to the late 17th century. So there was almost like 80 years or more of a span of observations. And Uranus's period is about 84 years. So with that various data, you could actually make a very precise orbit of Uranus. And this was a great thing. Now we knew where it is, how it moves, and so on. And we can predict where it is going to be next year, right, or whenever. Except that didn't work. This is a plot which shows the dots until this year, which is this where the arrow is. This is the discovery year. So everything before was they thought this was a star, but it actually was Uranus. And afterwards were the observations that people did, knowing that there is the planet, and knowing which path it should have. But what's on the y-axis is the deviation or the difference between the orbit that was calculated and where Uranus was actually measured. And as you can see, it makes these funny movements with years. This band is the error that will be allowed. So within this band, okay, you can move it wherever, but if these things obviously mean that there was a discrepancy between what people thought was the orbit and what it was. And this was essentially the biggest problem of astronomy at the beginning of 19th century. By 1840s, where our real story starts, the idea was that there must be another planet outside, further away from Uranus, that is pulling on Uranus. So now the usual story, how Uranus was discovered, Neptune was discovered, is that this guy there, John Couch Adams, as a young student, when he enrolled in Cambridge, found out about this problem and wrote in his diary, "I'm going to work on this thing as soon as I can." 3 years later, he finished his studies as the best student in math in Cambridge, and went home for vacation, and he started working on the problem, made a simple perturbation theory, and saw that it works. So he went back to Cambridge, started talking with the astronomers there, which connected him to the Royal Astronomer, so the main guy in England or in Britain for astronomy. His name is George Biddle Airy, that's him here, who was also very much obsessed with Uranus and did a lot of measurement. And he gave to Adams the data. And Adams didn't do anything anymore. He stopped working until 1845, where he, again on a vacation at home, made a better solution and was in a position that he thought he can show it to this Airy guy for a kind of approval. Now, before we go to the rest, I have to make a small digression, and this is that if you want to make, if you want to solve this problem of a planet influencing the other planet, you have one degeneracy, and this is what is the ratio between the mass of the planet and its size, and its distance from the sun, right? You can be more massive further away or less massive closer, and it's going to have the same influence. So you have to break this degeneracy in some way, and the way to do this thing, in this case, was to say where it is going to be. And the reason that they could do that, or they thought that they could do that, was this thing called Titius Bode law, which basically tells you what is the distance in astronomical units of a planet from the sun. And it follows a very simple power law, where m is number of the planet. So the Earth is the m equal 2, and you know that m it's at 1 astronomical unit. And when they discovered Uranus, it was perfectly spot on where this law was predicting where it should be. So the natural thing for Adams was to, and I forgot to say, when they discovered the asteroids, they were also exactly in the between Mars and Jupiter, right, where they were supposed to, where a planet could have been. So basically, Adams said, okay, I'm going to use this law, put it at the 38 astronomical units, and this is the breaking of the degeneracy, the rest goes into the mass. And in his calculations, using elliptical orbit, he actually was able to say the planet is there. You know, you can point your telescope and it's there on the sky. So then in the late September 1845, sorry, he went to Greenwich, to the Royal Observatory, and to the house of the Royal Astronomer, without being announced, and you can imagine that this is not what you're supposed to do. He knocked on the door and found out that the guy is in France. Okay, so nothing. In late October, he comes in the early morning, knocks on the door, and the butler says, it's too early, what are you doing here? I says, fine, okay, I'll come in the afternoon. He comes in the middle of the afternoon, knocks on the door, and the butler says, the family is at the dinner. You are not supposed to, you cannot be admitted now. But okay, what do you want to say? Here's the piece of paper, write a note. So he wrote on a piece of paper that is still kept his solution to this problem, left it with the butler, went to Cambridge, forgot about the whole thing. A few weeks later, Airy, full with his food, finally got to see this solution, and that intrigued him because he knew what is the problem, and he saw that there is some logic there. And he actually wrote a letter to Adams, says this is great, but what about, and then he asked a technical question, you know, how, as a referee would do. And Adams never answered that question. This is November 1845, remember the date. Okay, so we now move to Paris, across the ocean. This is a statue in front of the observatory in Paris, the old observatory in Paris, of Jean-Joseph Urbain Le Verrier, who started his astronomical career in 1839. He worked on Mercury, and at some point, this guy here called François Arago, who was like Airy for England, for French astronomy, he said, you should work, we are very smart, you should work on the problem of Uranus. And on the 10th of November 1845, Le Verrier presents to the Academy of Sciences in Paris and publishes a paper saying that there is no known body in the solar system which can influence in that way Uranus. 7 months later, or 8 months later, in June, he presents and publishes a new paper saying we have another planet that is outside and it is there on the sky. And then 2 months later, after 3 months later, after the summer, he says, it's not only there, but it is exactly there. I know where it is with a great error, and you can even look at it and you'll see it as a disk, not as a twinkling star. He was the theoretician. He didn't really know how observations work, but that was his prediction. Okay, let's go back to England. In end of June 1846, Airy receives the paper from France with when Leverrier predicted that the planet should be there. And he remembers, hang on, there was this young guy, Adams, who also said it was there. You know, 2 different people, different nationalities, everything you can imagine, they have the same result. There must be something very important. So he, takes his buddy Challis, who is the astronomer in Cambridge, and said, you should go search for the planet. This is the telescope you should use. This is the telescope there, Northumberland telescope, which it's a very beautiful thing to see, if you have the chance. And just look for the planet. There are 2 people that says it should be there, right? And indeed, around the summer 1846, Challis starts the search. Adams is participating, and just to do a spoiler immediately, on August 4th and August 12th, they actually observe a star that is Neptune, but for them it's only a star because they don't come back and check that it moved. Because they're making just a catalog of stars every night, and then they should come again to the same field and see what moves. They never did this, or well, they actually do it, but they don't check the data. And then on the 23rd of September 1846, the Neptune is observed in Berlin. On the 30th of September, Challis gets the letter that he was scooped. And that's it. You would say that's the end of the story, that Neptune was observed. But that's where the fun actually starts. Because on 3rd of October, just 2 days later that England found out about the discovery of Neptune, John Herschel, the son of William Herschel, writes in a kind of gentleman magazine kind of place, and writes a text saying that they had a guy called Adams who was also predicting where Neptune was. And did a good prediction. And on the 17th of October, in the same magazine, Challis and Adams write their sort of article about what they did, that they had the search, they had the prediction. Now they also use the position that now they found out in their data where that they saw it already on in August. So now they have the 30th of September and the beginning of August observations. You have a small arc on the sky. You can make a better orbit, and they present it, and they say also, we suggest the name should be Oceanus. French are not really, don't appreciate the gesture. They start talking about the planetary theft, and you can imagine the journalists get a field day. They start making all sorts of cartoons about Adams looking in the dark, but Leverrier finding the star, and so on. And on the 19th of October, 2 days after that publication, so essentially the moment they got the paper across the channel, François Arago says the planet is going to be called Leverrier in front of the Academy of Sciences. Only in November, Adams is actually presenting his work in a scientific way, in a paper, in a conference, which is very different from what Leverrier did. What was the German reaction? It's written in German, but the translation is basically, God give us that this is not going to be a political war declaration between England and France because of this thing. It became so hot, the thing. But let's go a little bit about this orbit and the prediction. So I said that they used this law, and this is where it was supposed to be. But actually, Neptune turned out to be here. So the law was broken, which made a bit of a problem because the orbit obviously was not correct. But then this guy, American Sears Cook Walker, went to some old catalogs and found that actually the Neptune was also observed on the 10th of May 1785, and people thought that this was just a star. Actually, the funny thing is because they even saw that this moved, but they didn't believe their observation. They saw that this was a wrong observation. They just kept one position or the other. They could have already discovered it. But with this now 50 or so years difference, they could have a good arc on the sky and get the orbit better. And here is the results of the orbit that Walker did compared to the modern, and this is the compared to the Adamson-Leverrier things. I'm going to show you in this slide how they actually looked. So this is Uranus orbit. This is the true Neptune orbit, this one here. And then the green and the yellow are the orbits that Leverrier and Adams predicted. And you can see how they're not the same orbits, really. To the level that some people started, being cheeky, starting, but did you find the planet that you were observing? What did you find? So now I'm going to go a little bit with formulas just to show you what the problem is and what it means to find Neptune. So let's start with the idea that we know that there is Neptune. We have, Uranus going around the sun, and we have Neptune going around the sun, and you can write their interaction, their motions as a coupled harmonic oscillator, which is driven by an external force. An external force is the Neptune's pull. And, you can do all these equations, but what is important is that we know the orbits, the orbital periods of both Neptune and Uranus. We know this. That's my proposition now. Which means that we also know the driving frequency. We know the time of conjunction. This is this T naught. So this is when the Neptune passes or the Uranus passes next to Neptune, right? Because it's faster. And we know, of course, what is the ratio of the radii. So you can solve this thing, this problem, relatively simply. And now, just to show you, this is the period of Uranus. This is the period of Neptune, and you can see that they are very similar by a factor of 2. That means there is going to be some resonance. And indeed, if you look at this formula, when there is a problem if there is a resonance, and in particular here, the difference between this omega 1, which is the Uranus, and the omega, which is the driving frequency, is close to 2. So they are in a near 1 to 2 resonance. So that, of course, is where things explode, and it tells you that the solution when this n is, so the second term in the expansion is going to be the most important. Now, here I'm plotting what is the influence of the external force, so the gravitational force of Neptune on Uranus, in the same plot that they used to show these deviations. So this is a difference between the predicted orbit from where it should be. And you can see how this amplitude is much bigger of this external force than what they are observing, or they were observing. In a way, you could say Neptune is not actually is not responsible for these perturbations. This is a way, but this is not, the problem is because they had it in a bit weird way. They thought that they know what is the perfect orbit of Uranus, and but actually you don't know that, right? You don't know what is the perfect orbit of Uranus, and that's why this looks a little bit silly. If you do the full solution, you get this kind of equation, and it has 3 pieces. This is the piece of the driving force. This is the piece of how precise is an orbit in terms of its size, so how far is Uranus from the sun. And this part is what is the shape of this orbit, how eccentric is the orbit. And actually what you can show is that perturbed orbit of Uranus, so the one that you observe, is like an unperturbed orbit, but with a different eccentricity. It's slightly different eccentricity. It's kind of elongated. So that is behind the whole problem. Okay. And if you then start putting all these terms together, this is the previous one, this is the external force. This part here is the change because of this eccentricity. And you can see, when you start adding them up, they, constructively or deconstructively combine, and you start fitting your data very well. But the difference in these frequencies between the driving frequency and the frequency of Uranus is not exactly 2. It is this thing here, or if you want, there is a beat frequency which has a period of about 4,000 years. And that means if you extend this plot here, you're going to get something that looks like this. And the fact is that the minimum deviations that happened at the time when people saw the Uranus and started observing and having this problem was also about 4,000 years ago when, you know, Cheops was building the pyramids. That is the last time it was seen. Anyway, now let's go back to the problem that we don't know that there is Neptune. We can solve the same equations. You get this red curve as a solution, and you can easily determine, you know, today this is a trivial thing in a way of a few seconds, that what is the period, and the period of the orbit of Neptune is 166 years. It's slightly wrong from what the true orbit is. The time of conjunction is also slightly wrong, and this is because actually when you do this inverse problem, you start approaching this resonance from a different direction. The result is that the driving frequency is slightly bigger than the natural frequency of Neptune, so you don't get exactly the same result, and this is the reason why they were actually not able to get the correct path, the correct orbit, even if they would know where the Neptune was in terms of distance, right? But what I want to stress is that for this time of conjunction, you have the main solution, but there are these two solutions as well, which is about 20% of the realizations that you can get, which are exactly half the orbit away. So if they landed into one of the local minima, you know, instead of pointing there, the telescopes, they would be pointing the telescopes there, and they would never find it, right? That is the thing. Okay, so now let's go to what actually happened in Berlin. The Neptune was discovered on 23rd of September 1846 by Johann Gottfried Galle, this is this chap here, and Heinrich Louis Daré, who is this guy over here, based on the prediction by Leverrier. They used this telescope. It's a beautiful Fraunhofer, made by Fraunhofer from Munich. It still exists. You can see it in a museum in Munich. If you have ever chance to go there, do have a look. This is the old observatory in Berlin, which doesn't exist anymore. I can tell you more about it later. How did they find it? In the morning of 23rd of September, Galle received a letter from Leverrier saying, you know, I have a great theory, there should be the planet, it's going to solve everything, can you look for it? Galle was an assistant, the only other paid astronomer at the Berlin Observatory, so he had to go and ask his director, Franz Encke, can I use the telescope? And the director said, well, you know, I don't believe in this Leverrier's theory, but hell, today is my birthday. He was 55 years old, so I'm not going to use the telescope, do whatever you want. And and then this guy, Daré, who was a student, essentially squatting in some back cupboard of the observatory, said, can I join? And Galle said, sure, no, why not? You know, open the dome, prepare the coffee, whatever, we'll do things together. And they will go there and they take this chart, which was done in 1822 by Carl Harding, as their guide, right? They're going to look at the chart, look at the sky. But when they try to do that, it doesn't work because the chart is not good enough. It is full of holes. This idea of Leverrier that they can see a disk of 3 arc seconds doesn't work because Berlin is not a great site. But then Daré said, but hang on, there is a new map of the sky of that particular hour on the sky, of that position, which is in the rector's office. You know that we are doing these things. And Galle says, yeah, and I have the key. So he goes to the rector's office, takes the chart, goes back to they go back to the dome. Daré sits behind the desk with the chart. Galle is looking through the telescope and says, okay, there's a star in these coordinates, and the Galle is doing, Daré is doing, okay, seeing it, until at some point he says, this is the chart, by the way, that's what they go through, and at some point he says, that star is not on the map. And that's about 10 o'clock. What do? They go break down the party, break up the party, bring the director. They observe for another maybe hour or less, but then the planet sets, and they have to wait the next day. And luckily it is sunny, or clear sky, not sunny because it's night, it's clear sky, and they see, and not only that they see the place, but they actually see that it moves that star in the right direction where the planet should be moving. So they did discover exactly what Leverrier said. And, you know, this is the discovery. Galev writes letters. Encke, so Franz Encke, the director, he writes the paper. He's the boss. This is in German, but basically what he says is that there was this is the translation if you want. There was a letter from Leverrier to Gale. We use the map, this chart that we are building, that we are making. This is our project. And it was very easy to find based on Leverrier's predictions where the star is, where the planet is. Very simple. But it has some consequences that are you know, until today. And that made the whole story very, you know, interesting. First of all, nobody ever heard of Davor and that he was even present. Second, there was a myth about easy discovery. You know, okay, it wasn't too bad, too difficult, but it was not easy. And there was also a myth about the special chart that was only in Berlin, and only they in Berlin could do it, and which was often justified by the English were using it to justify why they didn't do it before. Anyway, so let's talk about that chart. This is what I say, it's a German visionary scientific project, and the guy who instigated was Friedrich Wilhelm Bessel, you know, from Bessel functions and so on, but he was a great astronomer, really a very smart person, and he knew that the maps like the Harding Atlas, the one that they took first, are not complete. And if you want to find out planets or asteroids in the ecliptic, you need to have a better chart of stars that are there. So he proposed, actually just about 200 years ago, to the Berlin Academy, let's map this part of the sky. And he was, being German, he was very precise. He said, okay, you're going to do certain area above and below the ecliptic. You're going to divide it in 1 hour chunks. Each map is going to have 510 squares, 1 degree each, you know, very precise how to do it. You're going to pay people who do the thing. They're not going to do it for free. You're going to set up a board that is going to overview this thing, you know, it should be. You should cast them in copper so that you can easily print and to anybody who wants it, you know, so it's like a printable. You should write a paper about it. Obviously, very important. And he makes a trial chart, you know, he says it's doable. There is no problem. You just go and do it, and he does it probably in 3 nights, being Bessel. But they also invent, together with his student, Steinheil, they invent kind of an apparatus that helps you, you know, to look at the same time and write in the other time where the stars are. This is the list of maps that they made. The first column is the name of the main astronomer that completed the map, where it was done, and when it was done. 24 charts in 34 years. Not very efficient. 20 astronomers finished the charts, but there were 36 people involved. Academy Commission had 7 members in total. Out of original 4, 3 died before they completed the project. We don't know how many babies were born in the meantime. It was too long and too expensive, that's obvious. It was almost a failure until 8 December 1845, where Carl Ludwig Henke, using Hora 4, so this one here, which was by the way done in the Ukraine, observes a new asteroid called Astrea. This is important because for like 38 years, nobody observed anything new. So this is the first time, and it came because he had a chart, right? And then the next big thing was, of course, Neptune 6 months later, or 7 months later. Now I have to come back to this claim of Challis. We didn't have the map, so we couldn't do it, right? Why is that? And but that's not exactly true, because when Early was texting Challis, why don't you do your search? He wrote, there is only one map which applies partially to this inquiry, and this is this Hora 22, which is this map, which was in Cambridge, and it's known that it was there. But Challis doesn't follow that. He decides that he wants to do his own map. He's going to chart the stars himself. But then later he says, if I had that chart 21, then everything would be solved. I could do I could find it immediately. So let's compare the parts where this chart, this is 22 and 21, so they're adjacent, where they overlap. Each chart is always overlapping by 2 degrees, as you can see here. So if you place them on top of each other, they are almost perfectly aligned. So they did their jobs well. And now let me show you where Neptune was when they started observing in Cambridge. It was on the chart. And then this is where it was on the 4th, and where it was on the 12th of August when they saw it. It was on the chart. So they could have done the same thing that people in Berlin did. They just had to take a chart and look around, and that's it. But they didn't. All right, let's change the tack a little bit, and let's talk about the important things. And this is one is a silly thing, which is the scandal, and then the important thing for me, which is the omission. German scandals. The whole business of discovery of Neptune is such an interesting thing because there were a lot of complaints in England how people treated atoms before they discovered, and most of these complaints are actually just complaints. They're completely not true. Atoms was not well supported, actually, right? That's one thing. France had its fight actually between François Arago and Leverrier after Arago said that the planet should be called Leverrier. And there are even rumors about wives being involved and so on. You know, it's a soapy thing. But Germany has also its own funny story. And I came out of it by reading this paper, which was written by Leverrier to Schumacher. We'll meet him again. He's the person who publishes Astronomical German, Astronomische Nachrichten, where everybody is publishing at the time. And he writes, "I'm distressed to think that one might not be more reasonable in Berlin than in Paris." It immediately tells you how French and Germans think of each other. And there are indeed in some other letters some indications, like Humboldt is talking about a sad, sinister act. What is all this about? It's a silly thing. It is a complaint that Gale, who discovered, right, the observer, did not get a medal from the king for the discovery. You know, he didn't get his Nobel Prize because his boss didn't say that he should get it. And then they ask him, but the boss secured a higher salary from the king, from Gale. And then at some point, the scandal arose, so Encke had to answer, and he said, well, there was a guy called Henke, 6 months ago, or whatever, 10 months ago, who discovered the first planet after 38 years, asteroid. You know, did you give him the medal? No, you gave him more money, so what do you want? That is their explanation, but it is a kind of a scandal that was there and people were discussing it. Now, the thing that bothers me the most is this question of what happened to Daré. Why was he completely ignored? And the fact is, in the letter from Gale to Leverrier saying we discovered, he basically says, I found an 8th magnitude star, which is Neptune, right, that thing. Later on, Encke, as I said before, is talking about a letter to Gale, the map, all these things, but nobody mentions Daré, who was there, who was working, right? And nothing got mentioned until Daré dies in 1876. Daré actually had a very good, very illustrious astronomical career. He got a gold medal from the Royal Astronomical Society for his work and so on. So he was a famous astronomer, and he gets an obituary written by this guy here, John Dreyer, and he writes it in German to a German paper, and he says basically here that on the 23rd of September, Daré was Gale's assistant when they discovered the thing. That is the first mention. He doesn't, for example, mention it in the same obituary he writes for Monthly Notices, the British Journal of Astronomy. But anyway, it's out for the first time. And the sad thing is that Leverrier died also in 1876, and he never actually found out that I was present. He only thought that Gale was there. Okay. So the correct version, the one that I explained you, that I told you, came only after this mention in 1877. Gale, probably irritated a little bit by that mention by Dreyer, actually writes a short article explaining what happened. And here he puts the prominent role of Dare, what he did, how he wanted to join, how he provided the idea for the map, and so on. Then in 82, Dreyer tells his story, how he heard about that, because he was a student of Dare, and they observed together, and then, what do you do when it's cold and by the sky? You tell stories. And then there is another exchange with Gale. So basically in 1882, by 1882, now everybody should know. But as a fact, these are just these papers, as a fact, in many other books in Germany that came out in 85, 86, 1969, that discuss general astronomy, nobody ever mentions Dare. And even today, in many publications, this is just one recent in English, only Gale is mentioned as the one who observed Dare. And what bothers me the most, I don't know if you can see it, but this is a picture from Wikipedia about the names of various rings around Neptune. There is Gale ring, there is Leverrier ring, there is Adams ring, there is even Arago ring, but there is no Dare ring. That's not fair, right? But that's how it is. We are here to correct this thing. So if somebody asks you who discovered Neptune, you say Leverrier predicted it, Gale and Dare observed it. Okay, so to finish up, let's talk a little bit about the naming of the planet. This was a scandal by itself. Traditionally, the discoverer has the right to name the planet. Doesn't work always, and for example, both Herschel and Piazzi who discovered Ceres, the asteroid, their names were not taken because they wanted to call these things by their kings. But the astronomers said, "Nah, come on, don't be silly." So Gale, when he writes to Leverrier, we discovered it. He says, "But can I suggest that the name would be the name of the planet should be Janus? This is a Roman deity of beginning and end, a bit obscure, I must say, But he suggests something as a suggestion, to which Leverrier immediately replies back. It takes 4 days for the letter to come between Paris and Berlin at that time. So Leverrier gets it, and in the evening he writes back. He says, "The board of longitudes here has proposed the name of Neptune with the trident as a symbol." Now, there is a big alternative truth to that thing. This is not true, simply. There was never a meeting of the board of longitudes that had this agenda. They did not name it. It was Leverrier who invented it, and he sent this thing in a letter to, this is the cutout from that letter to Gale that is still preserved, Neptune trident. But he also sent it to journalists, and that starts proliferating around that name. But then there was that suggestion by the British, Oceanus, Arago putting the foot down, it should be Leverrier. Then the Humboldt, whereas he's here, the famous naturalist, he says it should be Erebus, but he later calls it Poseidon instead of Neptune, just for fun. Encke, the director, you've seen him before. He calls it Vulcan, or no, he suggests. These are not official suggestions. These are only ideas that people are saying. Why don't we call it like that, right? This was the official one, and this was the official one. These are just in the letters between people. Many call it Leverrier's planet. So this is what you see in the journals when people observe the location. They just report the locations of Leverrier's planet. Then there was the idea of Minerva, Hyperion. Gauss, the famous Carl Friedrich Gauss, says Leverrier is just improper. We're not going to use it. He also, in one letter, he calls it Adams Leverrier's planet. He's the only person who said, it should be called by the two predictors. And then there are also two funny instances. This guy Schumacher that I was saying, he has a great correspondence with Gauss, and he says, I can't take this Neptune in the sky, seek animals, horses, the seahorses, dolphins, and stuff on the sky. That doesn't work. What is this? You know, you cannot put a Neptune in the sky. Gauss has a better story. He was at the party, and he talked with some guy, and that guy, very witty apparently, suggests it should be called Bacchus, and the symbol should be a glass, because, as he said, the god who made the old dead Uranus stumble could be none other than Bacchus, right? And he finishes, which at the same time will satisfy perfectly the ambitions of Leverrier, because they think he's, you know, some dude that wants to put his name up. So anyway, people are having fun. These are private letters, right? Nothing like in England where they put it in the newspaper. But what happens is that the Germans, and particularly these two guys, the director of the Berlin Observatory and Friedrich Struve, director of Pulkovo Observatory in Russia, in Imperial Russia, they basically say, they decide. But before that, I should mention that Airy is checking out with his German friends, what are the people thinking in Germany? Like, are we going to call it Leverrier? Are you serious? To which he gets back, no, it is, you know, that doesn't work. So they decide they're going to call it Neptune in their almanacs, because every year the observatories have to produce these almanacs with ephemeris and so on. Encke says it's a mythological name. Board of Longitude said it, right? That's the information he says. And Gauss likes it. That's for him, it's important. Struve says mythological, Board of Longitude, and John Couch Adams was also the predictor, so you can't just put Leverrier. And Airy publishes this letter again in that magazine, and essentially from that time and from the influence by the continental, you know, German and English astronomers, that's how the name gets imposed. But Airy was really waiting to hear what the German astronomers meant. And there is a beautiful quote that comes from this Admiral William Henry Smith, who was an amateur astronomer, member of the Royal Astronomical Society. He says, "I don't quite like this proposal change in the nomenclature of planets." This is from mythology to the names of the people, right? Leverrier, so Herschel is good name, right? That's English part, so it's okay. Leverrier somehow or other suggests the idea of a fabricant, right? Manufacturer, that's kind of base, no? That's French. But just think how awkward it would be if the next planet should be discovered by a German. Bugge, Funk, or your hirsute friend Boguslavsky, right? That's what he complains. So let's now just remind the good old Admiral about the discoveries and the discoverers. So Uranus was done by Herschel, a German working in England. Ceres was discovered by Piazzi, that's true, but then it was lost, and it was rediscovered using Gauss's prediction and by this guy called Olbers. Olbers discovered another asteroid, then came Carl Harding, who discovered another asteroid, another German, another Olbers, again Olbers German, and then after, as you can see, 38 years, Henke discovered Astrea using the maps. And of course, the Neptune was discovered by Gale and Daré, based on French predictions by Leverrier. So that much about the names. Okay, this is my last slide. I just want to say that for good science, you need time and you need money. There is no way out. That's how it is. A case that I showed is the making of the Berlin sky charts. But the same thing is with things like HST, JWST, ERT. All these things are just blowing over their budgets. They're late, but when they do come, they deliver something that we didn't even think of. Right? That's what is what it takes. And here on this plot, you see the progression in the number of observatories with time in a few countries. In France, England, Germany, and USA. So we are here in 1840s, and you can see that Germany is the country with the most observatories, while very soon everybody is overtaken by USA by a factor of many, right? It is obvious. So I'm going to end up with a quote by an American president. Now, that's not very smart thing to do these days, but this one is good. The progress of a people or a nation on its career of civilization can be gauged by the number of observatories on its soil. And you should build observatories, you should have good astronomy, and you'll be a civilized person. Thank you.
Okay, so thank you so much. Actually, I forgot to say that this is event, cultural event of the Chamber of International Relations of CCMN. And we did this because we wanted the students not only learn mathematics, but they have a more broader experience, meeting scientists from other country. So this is an invitation if someone has an idea for future events. This was brought by the observatory. Please tell us. Okay, we are very happy. So question? Yes? No? We have an historian here, German historian here.
A German historian, my goodness.
Yes.
My goodness.
Yes, say it, please.
Does that work? So, for this, okay, yeah. Well, thank you very much, Davor. I think you're definitely right. I think this provides a lot of meat for a mini-series. I agree. I was just curious how you're interested. I mean, I know you work in galaxies, and I was just curious how this caught your interest. And the reason why I'm asking is because, as you know, and we know, a lot of scientists are forgotten from history, especially a lot of women. I mean, you mentioned Carolyn, but I mean, there's so many women that have been in Arest's position, and I wonder how this actually caught your attention of kind of recuperating people who have been lost from scientific history.
Well, I mean, thank you. I mean, it is of course it's a chance. I mean, I am interested in history of science in general, and then I was on I had a dinner with the director of my institute, Matthias Steinmetz, and we talked about about Potsdam astronomy there, and then he told me the story about the discovery of Neptune. And that seemed, I mean, that's such a cool story. So then I started reading up a bit about it. And then I noticed the fact that in this British literature, very little is really said about German side. I mean, there is some German literature, which, I mean, it is fairly substantial, which mentions many of the things that I said, but this is essentially not known in the, outside of Germany in a way. So that seemed to be a very interesting thing to, kind of dig around and then some opportunities came, and I joined the team that was writing a book about Neptune, and that's where I developed the whole thing. But it was a chance. I'm interested in history. Our director is also very much interested in this thing and knows essentially everything there. So it kind of came, and then I found some things to. I wanted to also experience what it means to be a historian, to go to an archive, to go to dig into these letters. You get these letters and you first can't read what they're writing, and then it's in a different language that you don't understand. So it's fun. It's actually really cool.
Actually, yes, I have a comment and a question that, if I remember from the math point of view, in the 19th century, the Germans were sending articles to be published in the French journal. And by the end, more or less, if I don't remember exactly, which is the end of the century, so on, the Germans decided, okay, now we will have our own journals, and we're not going to send any more to be published in French. And this caused a 40 years gap in geometry, because the Germans were advancing in the geometry, the French geometry, and so on. And so the French had to resolve to send graduate students to Germany, because the students maybe were faster to learn German than professors at a certain age, and to bring back the things. So was the same happening with astrophysics, where astrophysics also published generally into the French journal? Or
no, not exactly. Basically, at the beginning of the century, this guy that I mentioned him, but I can dig his picture, Christian Schumacher. He was an astronomer. I mean, they're all sort of amateur astronomers, gentlemen astronomers. They're not employed as such, but they do it for fun. he started a journal called Astronomical News, Astronomische Nachrichten. And that was in the beginning of the 19th century. And that became, for majority of non-French or English speaking, the main journal. And in the opening letter or opening paper of this journal, he really says, you can publish in your language. It can be in Latin, it can be in French, German, English, whatever. And as you see, this really happens. But it becomes then very nationalistic. You know, this is the time when Latin loses the primate in sciences and the national languages become. So I think these people, at least astronomers, they were reading more than one language for sure. British people had their own monthly notices of the Royal Astronomical Society, which was going on for or after the same time. And the French were publishing in their academy, mostly. And then, of course, each observatory had its own yearbook or something like this, where they could also publish some papers, right? So it was a very heterogeneous, and also in many languages. But on the other hand, for example, Gale, he wrote his dissertation, his PhD thesis in Latin, and sent it to Leverrier, as you know, as you would distribute your paper, because he knew. He wrote the thesis about Mercury, and Leverrier at that time was the one who was doing Mercury. He was famous for that. So, yeah.
Thank you, Davor. It's just a fun comment, because about naming Neptune Bacchus instead, and with a glass of wine as a symbol, would be also funny and interesting, because Leverrier in French literally means the glass maker. So that will make it even funnier. Maybe that's why Gauss mentioned it. I don't know.
I think, you know, that could have been also one of the jokes that they had at that party. And it seemed to be a good party. Yeah, yeah, thank you.
I'm wondering about the number of the distribution of observatories by countries. You had shown at the beginning how decentralized was Germany then, and you show there are just 2 observatories, whereas France, as highly centralized country, has 4. So that's a bit funny. This is this difference. But anyhow, for Germany, I think the 2 are Göttingen and Berlin. But I remember of Bonn, because Argelander, he became constructed there an observatory too.
Yeah. No, these numbers, sorry, just to make sure, this is just the number. It's not the number of observatories. This is the number of observatories. This is just the number, the legend of the map.
Oh,
so
sorry.
1 means, because the 1 means in the caption, where I took this figure, 1 means USA, you know. So this is not the number of observatories. It's so in 1850s, Germany had about 15 or maybe 12, 13 observatories. So yeah. But I mean, I can say this guy Hermann, I forgot now, but there is a catalog that was published of these observatories, and it's in the reference. I can find it, and they all are numbered. I mean, so it is easy to verify this plot in a way.
What happened in the U.S.? Did people start observatories after John Quincy Adams suggested, was some other?
This is after the Civil War.
Yeah, but there is a linear growth between 1825
this thing,
and maybe
this is in the 70s. So this is in the 70s, right? So this is 60, 70, and about 80. Yeah. Well, you know, this is how America becomes. That's when America becomes the rich industrial country. You know, after the war, the Civil War, they really are starting to advance in many things, and just to make sure we understand, almost all of these things, or if not all of them, are private observatories, right? Okay. There is not. I mean, there is the U.S. Naval Observatory, which is funded by the government or by the Navy, and I don't know, maybe there is 1 or 2 others, but all others are privately owned. at least privately owned from the universities, but privately owned observatories. Right? Very different from Europe in that respect as well.
Perguntas? Os alunos? Não?
I have not.
No tem pergunta aí?
No?
No? I'm just taking advantage of this moment to discuss this, what you have just said about the privately owned. I have heard this has more to do with the way that people do science in the US and in Europe, and I'm just astronomy. Okay, so maybe it's different in other places, and here I'm actually not even talking about Brazil, because at least in astronomy, a lot of the main things that are happening usually are either in the North America or Europe in general. There are other growing places, but very often, like I wanted to get a little bit of your perspective about this interaction and groups. There seems to be much more collaborative approach, like big groups working to do science in astronomy in Europe, versus in the States it seems to be a little much more like there's one PI with like either private time or just very time that has been allocated for his or her unique project. I don't know if this connects. As you have been looking through history, is this something that has its roots from things that happened in the 1800s or something like that?
No, I don't think so. I think at least in Europe, the wars really made the big changes, and everything started being different. And after the Second World War, when European astronomers, first the continent was destroyed, and then there was also the fact that the American observatories had bigger telescopes and were doing better science. There came the idea, well, we can do the same thing, but only if we pull our resources together. Yeah. And that was, of course, the starting of ESO, and 50 years later, that's the best observatory in the world. But it took some time, and the fact that the resources were being centralized to some extent. So it's. But if I have 2 minutes, I have a funny story about how you build an observatory, and I want to show you. So I said this is the observatory in Berlin. It doesn't exist anymore, this building, because in the beginning of 20th century, they actually sold the ground to the developers, and in order to move to a better site. So that's why there isn't anything. But in order to get this observatory in 1820s, there was a trick. The Humboldt, who was the main kind of the most prominent scientist at that time in Berlin, and direct mouthpiece to the king, he said, okay, we need first a new director of observatory, and then the observatory needs a new equipment. And the observatory is in a complete disarray. It's above some stables with horses below and stuff. We need to make a proper building. How we do it? First, you're going to get an instrument which is first class. And he did this thing, and he also did it in a way that he approached the manufacturer directly, not saying that this is for the king, because the king is paying for everything, but that he is paying because he knew that this is going to keep the price down. So he got this beautiful instrument, and then he came to the king. We got it. As I said, we're going to do it cheaper, right? We did a good job there, even though the king paid. But then he said, but look, now, this instrument, you cannot put it above a stable. You need to have a proper place to put it. And then the king said, okay, what do you need? You need that thing there, right? And that's how they got this beautiful observatory as well. So one thing that I think we need to be, as astronomers, we need to know how to talk to money makers and the politicians, how to convince them. And Humboldt was a par excellence such.
Thank you so much. So let's thank again Professor Davor.